We're going to be learning about applications that you can use with logarithms, and there are applications with logarithms. We're going to go to the next slide and talk about common logarithm. The common logarithm is simply a log with base 10. And a common log with a base 10 means numbers like 10, 100, 1000, any 10 with any exponent. Now we're going to spend a little time doing some exercises on the calculator. We will be using the calculator for this. Well, what I want you to start with doing is begin with putting 5 to the 4th power into your calculator and then see what you get. And what you are going to do is do 5 with the caret symbol, 4, and then you will end up with 625. Now to find the 4th root of a number, you're going to enter the root first, whatever that is. In this case, it's 4. On your calculator, you will go down to Math and find this option. It's going to have a little X with a square root symbol with a radical. And what you've done is put in the 4 for the X first, and then you will enter 2401. Press the Enter button, and the answer that you're going to get is 7. So that would be the 4th root of 2401. Now the log key on a TI-81 or TI-83 calculator is down the left side of the calculator. It is the 4th button from the bottom, or it is the button next to 7, or the button underneath the x squared. But what we're looking for, this is the same as saying log base 10 of 100. But what I want you to look at is not writing that 10 in and realizing that you are looking at a base 10. And if we think logically about it, the exponent that takes a 10 to a 100 is 2. But I want you to enter this into your calculator, and you're going to write log 100. And when you press enter, you should get 2. Now, now we're going to look at log of 10, base 10, 150. If there's no base written, the base is 10. It's an understood base. Now, what you would think is, okay, maybe you multiply by 15. We're not multiplying, we're raising a power. So we're going to say log 150, put that in your calculator, and you're going to get 2.1761. And I do want you to round to 4 decimal places. And now what I want you to do to test this whole theory is I want you to put into your calculator to check it. And the check's not necessary, but it's more of a prove it to yourself. And I want you to put 10 raised to the 2.1761. Use the little caret button. And press enter, and it gives me 150.003. That's pretty close. So we could call that pretty accurate. Alright, so log 30. Same thing, press log 30, and what you will get for your answer is 1.477. Alright, we're going to solve some equations using logarithms. Now, when you have a exponential equation and you cannot rewrite into the same base, there's no way to do that, what we're going to do is use a logarithm, because the logarithm is the inverse of exponential. So we're going to write that down here. So log is inverse of an exponential function. And if you remember, when you take the inverse of something, you're left with an x. But we have a 4 here. So the first thing we're going to do, this is step 1, we're going to log both sides. And what this does for us is brings in the power rule Well, if you have a logarithm, no matter what the base, and you have a power raised right here, that means that that power can be taken to the front, right there. So I'm going to say x, sorry. Let's clean that up a little bit. X log 4 equals log 50. And then we're going to solve for x. So x is equal to log 50 divided by log 4. Now, we're not going to divide 50 by 4. Log 50 divided by 4 does not give us the same as log 50 divided by log 4. So you need to enter these both into your calculator separately. When you do that, you're going to get 2.8219. Now, the way that you're going to enter this into your calculator, when you press that log button, some of the calculators, mine does, offers you a parentheses like that. Make sure you close that parentheses before you do the division sign. Otherwise, it will divide that 4, and we don't want to do that. So this is what we're going to do, and that gives us the 2.8219. Now let's just experiment. And what happens if I do decide just to divide my numbers like this? And that gives me 12.5. But if I decide to do that, it gives me 1.0969, which is very different from my answer. So don't do that. Alright, 2 more examples of solving equations. So we're going to do the same thing. We're going to log both sides. And that brings our negative x down. Now, if you're comfortable with skipping the step of writing the logarithm on each side with the power still there, since the goal is to get the power down, then you can go ahead and move that negative x down right here, and you can go ahead and do that without having to go through that step. Alright, so now what we need to do, we're going to divide both sides by log of 1.5. So don't divide the 1.5 into 0.5, that won't give us our correct answer. And when we do this, what it gives me is a negative 1.7095. We're going to round to 4 decimal places, and then multiply or divide by negative 1. And there we go. Okay, let's try the last one. So we can't rewrite 2 and 40 with the same base. It's not possible. So we'll log both sides. And since the goal was to pull that power down, I'm going to skip that step. Like that. And then I'll divide both sides by log 40. Remember, log 40 divided by log 2 is not the same as log of 40 divided by 2. That's not what we want to do. Alright, and we end up with 5.3219. So what we're starting to do is figure out how we can use logarithms to solve problems. And in our next section, we will be solving word problems using this technique.